Okay, so this is going to be a super short video illustrating the difference between perimeter and area. So at this point, you've probably already learnt how to find the perimeter of a shape and learnt how to find the area, but you're often finding yourself getting confused, not sure when to add and when to times and that sort of thing. So that's what this video is going to hopefully try and illustrate the difference between them. So we're going to begin very quickly with just what each of them are, just in case you've forgotten, and then we'll look at some examples where we'll find the perimeter and area of both. All right, so firstly, what is perimeter? Well, it's just a distance around the outside, right? So it's going to be a length. So, if you're like walking along the outside or you're measuring the outside of a shape, the perimeter will just be that length. So we look at this first one here. If we wanted to find the perimeter, I'm just going to use a capital P for perimeter. So the distance around the outside, all we have to do is just add up the total distance or length around the outside of the shape. Right, so you add them up together, you end up getting a length. So in this particular case, the perimeter of this triangle would be 27 centimeters, right? That's how long it was around the outside. That's perimeter. That's what it is, and that's how you do it. You just add up the sides on the outside. Now, area is different. The questions often look similar, and it's a measurement, but it's a very different measurement. The area is the space inside a shape. And we often use these things called, well, if it's a small shape, we'd use a square centimeter, right? Ultimately, it's just a square that's a centimeter across and a centimeter long. That's what we call a square centimeter. And typically, for a small shape, if you were to calculate the area, what you're trying to work out is how many of these square centimeters would fit inside the shape. So I guess what you could do is you could split the shape up if you wanted. Not that I'd recommend this way, but you could split the shape up. It's 2 centimeters high, so I'll split it up into the 2 centimeters, and it's 3 centimeters long. So if we break it up into its square centimeters, you can calculate the area here just by very simply counting, right? This shape, how large was it? It was 1, 2, 3, 4, 5, 6. It was the size of 6 square centimeters, right? Notice how there's that little 2 above the centimeter. That's because it wasn't 6 centimeters, it was the size of 6 square centimeters. So that's how you find area, and that's what area is. Now, chances are you've probably learnt a shortcut for finding the area of shapes like rectangles and squares, where you don't break it up into its individual square centimeters. What you'd probably do is you've probably learnt to find the area. You just take the length, which is 3, and then times it by the width, which is 2. So in other words, the area would be 3 lots of 2, which gives you the answer 6 square centimeters anyway. Right, so this is what we call a formula. It's like a shortcut for finding the area instead of breaking it up and then counting each of the individual squares. But that's not necessarily what this video is about. We're just trying to illustrate the difference between the two measurements, perimeter and area. And let's move on and let's look at our first shape where we're going to find the perimeter and area of both. Now, if you've got this shape here, it's a rectangle. It's been split up already into its square centimeters. Now, if we were trying to find the perimeter, right, I'll use capital P for perimeter. Well, remember, perimeter is just a distance around the outside. All you need to do is ultimately just add up the distance around the outside. So it's 1 centimeter, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The perimeter is 14 centimeters. Or the way most people would do it is they'd say, oh, we've got 3 centimeters here, 4 centimeters here, and then what they might have done, instead of say we've got 2 sides of 3, which is 6, and 2 sides of 4, which is 8. And when you add them up, you end up getting the 14 centimeters, right? It doesn't matter how you add up the distance around the outside. For this video, I'm just going to be counting, right? But you will end up with the correct answer, which is 14 centimeters if it's done correctly. Now, the area has nothing to do with the outside of the shape. The area is the space inside the shape. How large is this shape on the inside? And to do that, we count up how many square centimeters are needed to make up this shape. So, for area, I'm going to use a capital A to represent area. And in this case, I'm just going to count them. These are the squares inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The area would be 12 square centimeters. Notice for this one, the perimeter was larger than the area, right? They're not going to be the same. Sometimes they are, sometimes they aren't. In this particular case, the perimeter was larger than the area, but that's not always the case. If we have a look at this rectangle, if we wanted to find the perimeter, right? So distance around the outside, 1, 2, 3, 4, plus the 4 on the other side. So we've got 8 so far. And now let's look at the top and bottom sides. What's the distance across the top? 1, 2, 3, 4, 5, 6. And then across the bottom will also be another lot of 6. So 6 and 6, that makes 12. So in this particular case, our total perimeter, the total distance around the outside, would be 20 centimeters. What would our area be? Well, again, you can just count up all the squares, right? 1, 2, 3, 4, 5, 6. The next row is another lot of 6. So 6, 12. Third row, another lot of 6, right? 3 lots of 6 is 18. And another lot of 6, 4 lots of 6 is 24. Ultimately, we had 4 rows of 6, or 4 lots of 6. You can just count them up, but I've used times tables to speed it up a bit. And the area is 24 square centimeters. So the first shape, notice the perimeter was the larger one, right? It was still a rectangle, but the perimeter ended up being larger than the area. Go on to this rectangle, now it's the area which is larger than the perimeter. So it's not always going to be the case where one is larger than the other one. You can even actually have a situation where they're not different at all. Here I've got an example of a square. If we go ahead and find the perimeter of this one, again, you can see each of the sides is 4 across, right? So if you want to find the perimeter, you just add up all the sides on the outside. They're all 4. You end up with, in this case, 16 centimeters. It's the total distance around the outside. For the area, again, remember for area, we're trying to calculate how many of these square centimeters, right? Remember, this is a square centimeter. Area is the space inside. How many of these square centimeters do you need? So you can go through and count them all up, and funnily enough, you end up getting 16. Or what most people would do is say, oh, we've got 4 lots of 4. Either way, you end up getting, for the area, 16 square centimeters, right? Even though it's the same number here, they're different measurements. Perimeter was the distance around the outside, area was the space on the inside, and in this particular case, the perimeter was actually equal to the area. So even that can happen. I guess what I'm trying to say is you cannot say that, the perimeter is going to be larger than the area, or area is going to be larger than perimeter, or even that they're going to be the same. It just depends on the shape. Do each one separately, work it out. There's no sort of patterns in that particular regard that are worth memorizing. All right, we've got one final shape we're going to look at together. Let's make this one a little bit trickier. Let's say we want to find the perimeter of this one. So again, perimeter is just distance around the outside, right? Pick a spot. Let's count the length to get right around the outside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. This shape had a perimeter of 22 centimeters. That was the length it took to go right around the whole outside. What would the area be? Again, area is the space inside it. How many of these square centimeters were there? Well, let's go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This shape has an area of 16 square centimeters. So it really is as simple as that when you're given shapes like this. It's worthwhile noting as our final point for the video, this shape here has the exact same area as this shape. They were both the same size as 16 square centimeters. Now, obviously this one here was taller, right? But it's because of the gaps in it between. Even though it's taller, it had the gaps. They ended up balancing themselves out. So the space inside them ended up being the same. They were both 16 square centimeters. Of course, what was different, it was the perimeter. Here, when you got yourself a nice even square, the perimeter was quite small. The moment you start cutting in and extending parts out, the perimeter ended up getting longer. Anyway, we're going to leave it there. Hopefully this helps, and best of luck with your maths. All right, bye.